In today's online session, we will be discussing experiment number 5 to verify the principle of moments in the disc apparatus. Its main objective is to verify the principle of moments using disc apparatus. And the statement says that if a number of coplanar forces are acting on a body, keeping it in equilibrium, and their moments are taken about any point in their plane, the sum of clockwise moments is equal to the sum of anti-clockwise moments. Okay, so this principle states that the clockwise moments should be equal to the anti-clockwise moments if a system is achieving equilibrium, right? And their sum about a point must be equal to 0. Moment is basically a product of force and the perpendicular distance from the pivot, which is the moment arm. In this case, one force is acting on the lever and thus it's not satisfying the equilibrium state. Why? Because the sum of moments cannot be equal to 0, and since there is no force being applied on either side to produce the moment and to cancel the effect of F1, that is why the system is not achieving its equilibrium state. F1 is being applied at this side, the right side, and D1 is the moment arm in this case. The clockwise moment would be calculated from this relation F1 into D1. And since there is no force on the left side here, there is no force, that's why the system is not achieving equilibrium, because there is not a balance. Here we have case number 2, in which we have two forces applied on either side of the lever, balancing the lever and achieving the equilibrium state. F1 into D1 is the clockwise movement and F2 into D2 is the anti-clockwise movement. According to the principle of moments, when state of equilibrium is achieved, it means that sum of anti-clockwise movements or counterclockwise movements should be equal to the sum of clockwise movements. In case number 4, it's showing a system where 4 forces are acting upon the lever. F1, F2, 3 and 4, right? 4 forces are acting on this lever. Each force is being applied at a specific value, and these values are basically showing the perpendicular distance from the pivot. And it is called the moment arm. The anticlockwise moments are shown by these relations. F2 into D2 is the anticlockwise moment and F4 into D4 is the anticlockwise moment. Similarly, the clockwise moments are F1 into D1, F3 into D3. Because for creating a clockwise movement, which is in this direction, probably F1 and F3 are responsible, right? And for creating an anticlockwise movement, F2 and F4 are responsible. So that is how the sum of anticlockwise movements and clockwise movements would be calculated. And according to the principle of moments, they should be equal if it's achieving the equilibrium state, only then. This is how the apparatus of the disc would look like, and you'll be needing weights, disc apparatus, and a measuring tape or a ruler. First, you have to set up all the apparatus before starting the experiment. Then, when no weight is attached, the hangers should be in equilibrium state. If not, first balance all the hangers, label the hangers, and put weights in each hanger in such a way to keep all hangers in equilibrium, and measure the length between the hangers. Number 6. Calculate the moment produced by the weights on left side of the center point and also the moment produced by the weights on the right side of the center point. Left side movements should be equal to the right side movements, and this is how the principle of moments would be verified. These are two precautions which you should be taking care of. Number one says that the weights shall be hung to the hooks very gently, and number two says that the pulley in the disc shall rotate freely. Now let's have a closer look to the apparatus. This is how the disc apparatus looks like. It has a pivot in the center. First of all, you have to balance all the hangers, right? This means that you have to attach the hangers to the disc apparatus, and you should make sure that no wibble wobble occurs and the system is at rest in equilibrium. And after that, what you have to do is you have to label each hanger either alphabetically or numerically. It's up to you, totally up to you. And then you have to place the weights on the hangers, and you have to balance it as well. Okay, so these are the line of actions of forces. W1 and W2 are causing an anti-clockwise movement, as you can see, and W3 and W4 would be producing a clockwise movement. Now, what you have to do next in the apparatus, I told you before that you have to use a ruler or a tape. So this is where the ruler or tape is to be used. You have to measure the moment arms, all the distances from the hangers to the pivot, right? You have to measure all these values. You have to measure D1 and L2. The perpendicular distance of F2 from pivot is equal to L2, right? This is L2, and by adding D1 and L2, you will be getting this complete distance, which is from W1 to the pivot. So you'll be needing this distance when you calculate the moments in the end. Similarly, you have to measure D4 and L3, which are these. And then you have to measure D4 and add it to L3. This will give you the complete distance of weight number 4 to the pivot. That will be the moment arm basically. Then you have to take off the hangers and the weights, and you have to weigh them all together. Okay, make sure that the hangers are also included in the weights. If you miss them, you are wrong. You have to do it all over again. The subscripts W1, W2, W3 and W4 would be denoting the weights and the hangers all together. So when you note down these values, you should be very, very sure that you have added both these weights, because if you miss them, you'll be creating a big mistake, right? So make sure you do that. Once you have all the values, you have W1, W2, 3 and 4. You also have the moment arms. So you have to fill in all the values of experimental data into your table, into the data sheet. This is how your data sheet would look like. You have all the weights, the moment arms. You just need to calculate the clockwise and anti-clockwise moments and see if they match or nearly match. These are the readings which I took, and that's how the anti-clockwise moments and the clockwise moments would be found out. So the values come up to be 7.75 pound-inch for the clockwise moments and 8 for the anti-clockwise moments, which means that if you round this value to the nearest, so you'll be getting 8. So both these values are matching, verifying the principle of moments. So hence your principle of moments has been verified using the disc apparatus.